Today we're going to be looking at the acing AP, Calculus AB, and BC book, and this is by, let's see, Thomas Hyun. I hope I'm pronouncing that correctly. But what I like about this book is that it always gives you like a few key points before actually giving you the practice problems. So if we take a look at chapter 1, it's on limits in continuity. And 1.1 is all about rates of change. So even right here, right, if we look at the graph they're giving us, we can see how it resembles the slope. And basically, you could think about the average rate of change as like the rise over the run, which is slope, over a secant line. So here they tell us geometrically the rate of change is the slope of the secant line through the points P and Q. How that builds later on is that if we're thinking about the intervals, let's say A and A plus H, as we shrink the distance between these 2 points, and if we shrink it like big enough so that it approaches 0, then that's going to transform us into the instant rate of change. So that would be, like, let's imagine we end up reaching that point. That would be like the tangent line, which is essentially the derivative. So we'll build on that, but for now, keep that in the back of your head. And all right, so then let's solve some problems. Question 1. The traffic flow at a particular intersection is modeled by the function f, defined by f of t equals 25 plus 6 cosine x over 3. I'm pretty sure they meant to put t instead of x, so that's a typo on their part. For the interval 0 to 120. What is the average rate of change of the traffic flow over the time 30 is less than or equal to time is less than or equal to 40? Okay, so here they're asking us about the average rate of change. Based on our notes before, we know that the average change is just going to be f of 40 minus f of 30 divided by 40 minus 30. Okay, so then f of 40, we just have to plug that in. So we can do f of 40 equals 25 plus 6 cosine 40 over 3. And since we're measuring it with cosine, let's make sure that we're using radians. Once you plug that in to the calculator, it's going to be roughly 29.3205. If you do the same thing for f of 30, you're going to have 25 plus 6 cosine 30 over 3. It's going to give you roughly roughly 19.9656. Now, plugging that into our formula here, we get roughly 0.935, which is going to be C.